Click the bell icon to get latest videos from Ekeeda.
Hello friends, today we will talk about concurrent execution in this transaction. We will know what is in concurrent execution, and then we will talk about the advantages that we can achieve through the concurrent execution, and then we will introduce one schedule and the transaction, how it can be put into the schedule using this concurrent execution. The transactions till now we have known that this is a set of operation or a collection of operations that are performed together to perform a meaningful task. Now when the transactions are there, that means there are more than one transactions that we can include. We can have that inside the schedule. Now the concurrent execution of a transaction means that one transaction and another one can execute concurrently, whether to have a destroying the prevent the concurrent execution on this consistency. That means even if the execution of this transaction are done being in a concurrent basis, they will not provide an inconsistent result. Now the concurrent execution becomes extremely impossible because of these next two cases. The first one is an increased throughput and the CPU utilization. Say if we have two execution on the transaction. Now the transaction can be mixed like this IO oriented or in CPU oriented. Now when it is an IO oriented, then it will take a much more IO time lesser than CPU time. Say suppose transaction TI which is IO oriented. Now there is on transaction TJ that is CPU oriented. Now, if we can provide these two transactions not going concurrently, that means while the TI is completing its operation, TJ must wait for it. Now the TI is IO oriented mean it will have a lesser task than CPU, and the TJ is CPU oriented which will have a lesser task on IO. So when TI is performing, then the CPU becomes idle for that case, as it is the IO oriented operation. Now as this TI is performing all the IO orientation, the CPU cycles will not be used in by other transactions as they are not concurrent to each other. Now when TJ will happen, then we can say that it will be an CPU oriented, so my all IO oriented task will be idle. So now say TJ will perform on a CPU oriented cycle which will result in the IO oriented by the TI. So now TJ is being performing and TI is being waiting for that task. So we can go for hand in hand like the CPU and the IO but not concurrently. So what will happen if we make this TI and TJ concurrent execution with each other? Then while the TJ is having its CPU oriented cycles, TI can make the result of the CPU partially committed and then it can perform its IO work on this one. So it will increase the CPU utilization as well as it will increase our throughput. So what do you mean by a throughput? The throughput is generally considered to be the time of work done divided by the total time. So if the time of work done is greater than this total time, say for the total time of TI and TJ is 15 plus 15, that is equals to 30 seconds. So now my total time is 30, and if they are considered to be orientation on a concurrent basis, say for 10% of this TI and 10% of this TJ is happening with each other at the same time. That means it will go for 1.5 plus 1.5, that is equals to 3 by 30. So 110 is my throughput. Now when it is happening, say for non-concurrent basis, so only 10% of this TI will be performed. So now we can have that 1.5 by 30, which is 0.5 by 10. So it is much lesser than this throughput while we are having a concurrent execution. So now we can have an increased throughput and also an increased CPU utilization. So what happens now? Next, it becomes 1.60 in that case. So now we are having a throughput increased, on the basis of which the CPU also be utilized greater, because while the TI is performing its IO, TJ is not wasting its CPU cycles, which is very much expensive. So now it will become less expensive too. The next one is reduced waiting time. See, for some transactions are short time oriented and some are long time oriented. Say TI is having a wait time for a 5 second and TJ is having a wait time or an execution time of 43 seconds. So that TI, for doing its 5 second, it needs to wait for TJ to complete its 43 second if TJ is preceding TI. Now we can say that TI needs to wait for 43 seconds interval to perform its 5 seconds task. So it is always not desirable to wait such a long time for a shorter transaction, which will increase the average response time. So our system will need to reduce the average response time. If TI and TJ can concurrently execute, then TJ would have waited for, say, a block time of 10 seconds. So after 10 seconds, there will be TI performing its 5 second. Then after 10 second, 10 second, and like this TJ will finish its execution. So now we can have an rounded buffer of 10 seconds, which can provide this concurrent execution based on a timestamp. So now that we are considering a concurrent execution of two transactions, then we can say that the transactions can be put into a schedule. So what is a schedule? A schedule is said to have two transactions or more than two transactions involved in each other, where they are performing similar kind of task, or rather more precisely are accessing to the same data items based on these transactions. And the schedules can have these transactions either in a concurrent basis or in sequential basis. Now let us consider two transactions and then we can describe the serial schedule, and how we can implement this in the concurrent execution. First, let us consider the transactions on two banking systems. Our bank accounts that we will involve is A and B. Now we will consider two transactions on each. The first transactions we are having is to read the value of this B, then deduct an amount of 50 from it, and then add that amount to this A. So we can write it this. Now another transaction T2 also deals with these accounts A and B in a different manner, that it removes the balance of account A 10% from it and then adds that 10% of that balance of A to the account B. So now in T2 we need to read the value of A, then we need to, in a temporary variable, have the 10% of A, and then we will have A reduced with this 10% that it is deducted from it, update the account of A, and finally we can update B with it. So here we are having two transactions with each other on the same accounts. Now how we can describe a schedule based on this? A schedule can be either the T1 followed by T2 and then T2 followed by T1. We will describe each of this case to see that consistency is maintained or not. And then we will introduce what is a serial schedule. First we are having T1 that is performed before T2. So now first T1 will appear here. We are reading the value of A, performing A by deducting minus 50 to it, updating the value of A, again reading the value of B, updating it, and then writing the data back to the result to B. Now what happened when we try to introduce this T2 after this T1 in the schedule? So this read A will be performed after this write A. That means the value that is updated by this T1 will be read by this T2 because T1 is happening before T2 on this schedule S. So now we are producing a schedule where T1 is happening and after T2. Again, when we are reading this value of B, then after it is happening of this write B, so now T1 will be affected this T2 by updated value it is reading by T2. Now again go back to our previous example and see this schedule that what happens with the account A and B if we produce this one. Say the A of B value 1000 and 2000 respectively. So now as T1 at its entirety will be performed first. So now we are reading the value of A that is 1000 minus 50 that it becomes 950. Write it to A, that means now my A becomes 950. Reading the value of B that is 2000 plus it with 50 that is 2050 and then writing the data to B. That means my B becomes 2050 here. See that for the consistency checking, we know that the previous result on this whole will be an unchanged one with this consideration of new one. That means if we just recalculate it on this transaction, we will get back the exact same result that was pertaining the old values. So now my old values were 1000 and 2000. Now we have not completed the schedule, so it is not the final result that we are having. We need to perform this T2 again on this one. So now we are reading the value of A that is 950. We are calculating a temp that is 0.1 of A. So now my temp we are having as 95. So my value of temp is now 95. Now what we are doing, A equals to A minus temp, so we need to reduce 850 on this 95. So it becomes 855 now. So my A becomes 855, that is the final value of A. Now we are writing that to A, so A is having 855. What is B? We are B reading with 2050, adding this B plus temp, that means 95 will be added to it. So now it will be 2145. So now if we add A plus B and add this A plus B, then both the result will be 3000. That means the data is consistent in this way. So we can consider this schedule as an consistent schedule because the ordering on this T1 and T2 we are producing is having a consistent result. Now, if there is any other schedule that we can make on these transactions to make a consistent schedule, yes, just check for it having the T2 with T1. That means T2 will be preceded T1. Now we will perform the same with T2 preceding T1. So now T2 will be performed first. So all the operations of T2 will appear first in this schedule S dash. Now T2 has performed all its operation. Now T1 will continue with its operation. Now what happened, it will perform this A and B with the same schedule with the operations transactions reversed in this order. Now T2 precedes T1. So again take that example of account A and B with 1000 and 2000. So my initial sum is 3000. Now we are performing, that is 1000 on A we have read. Now 10% of 1000 as temp, which is equals to 100. Now we are performing A equals to A minus temp, that is my A becomes 900 now. And then we are writing the data to A, that means A becomes 900 on the database. Now we are reading this B, that is 2000 B equals to B plus temp, that means 2000 plus 100, that is 2100 now. So now what we will have? We will have to introduce this right B. That means we are having 2100 as a result of B. Now, if we are reading this A, that means we will read the value of 900 now, not the value 1000, because we have performed this right A and that is done in execution with this T1. So now we are reading 900, A equals to A minus 50, that means 850. We are writing this value to this A, that means 850 is my final value for A. We are reading the value of 2100 plus 50, that becomes 2150 for this B. Now if we add this 2, this will also add up to 3000. That means the data is consistent. But see, the different results are there. While performing this T1 and T2, we had 855 and 2145. Now for T2 greater than T1, we are having 850 and 2150. So if there are n transactions on which a schedule is made, that means if S is made of n transactions, then S can have n factorial schedules on which they can have the ordering execution among them. So there are n factorial schedules that is possible of this n transactions. Now why we are considering this as schedule? Because it is containing 2 or more transactions in a single unit. Now this schedules S dash and also S we were considering as a serial schedule. What is a serial schedule? Where all the operations that belongs to a single transactions are appeared together in the schedule. So it is not like that some of the transactions in T1, then T2, then again T1 we are performing. We are having T2 first, T1 next, or T1 first, T2 next. So this is by the atomicity that we are concurrently having. Now we are talking about the concurrent execution. Let us back to our discussion. So how we can achieve this concurrent execution? If the T1 and T2 both goes hand in hand at the same time, then we can say that we are having a concurrent execution on a schedule that is having T1 and T2 both going simultaneously, which will increase throughput, the CPU utilization, and reduce the waiting time for T1 and T2 both. Now let us consider a schedule that is having T1 and T2 executing concurrently. Now when we are performing T1 and T2 concurrently with each other, then we can context switch between them. That when T1 is having, there is a request for T2, it will switch back from T1. That is the updation that T1 is making or T2 is making will be stored, and T2 will store and start with that updation that T1 has made to this data. Say suppose that T1 is having the first part, that is reading of A, subtracting 50 from A and writing back to A, that appears in T1 first. See, while having the concurrent execution, one thing we keep in mind that you cannot change the ordering of the operation inside a transaction. That means whether this read A50 and write A will be in the exact order they appear in the transaction T1. We cannot have write A50 and then read A. We must reserve the ordering. It may change that the ordering among the transactions, but not the ordering among the operations on the transactions. Now if it has performed this reading of A, for the T2 it will perform its part of this reading. So in T2 the A's ordering is done first, and then we are again going to this T1. So here we can see that we are having this read A 50, then write A, and after that read A. So when we are having a concurrent execution, other than having the ordering of the execution to be precisely storing inside the schedule on the concurrent execution, the another thing that we need to maintain is that if it is any read that on transaction is having, it should follow the write operation for another transaction. That means if we had this read A, after that write A, or this one preceding this read A, or read A and read A both comes to hand in hand with each other, then there will be a problem and we cannot consider that a part of this concurrent execution. So now let us perform this on this account A and B and see what is the result that we are having. So at first my A had 1000 and B had 2000. So on this schedule we will first read the value of A, that is 1000, 50 deducted from it, so it becomes 950, and write that value to A. So my final value of A till now is becoming 950. Now what we are doing, we are reading the value of A. That means we are context switching it. We have switched the save state from this T1, that it has stored all the updation that it has made, and now it is going to another T2 as a context switch. So now it will read the value of A, which will read by 950, provide and 0.1, that is a 10% of it. So my temp now become 95, and now what it is performing, A is equal to A minus temp. That means my A becomes 855 now. So now I have written this A, that is my final value of A becomes 855. Now it is performing 2000. That means the read B is 2000. It is having B equals to B plus 50. So now it becomes 2050. Now it is writing the value of B, that is my B becomes 2050 now. Again what it is doing, it is reading the value of B, that is 2050, adding the value of temp to it. That means now my 25 will be added to it. So my temp become 95, it will be add to 250, and B becomes 2145. Now we can see that we are reaching in state that is 3000 and the initial value was 3000. So see, it is not always necessary that if we are performing in concurrent execution, it will be lead us in an inconsistent state. Here you can see that if we make the blocks on these transactions properly, then we can have the concurrent execution of the transaction in a schedule with and consistent data to it. But it is also possible if we do not maintain some properties to it, we are leading in an inconsistent state for a concurrent execution. The next one we will consider to see and look for it if it reaches for a concurrent execution with a non-consistent schedule. Now see what we are having, the read A and A equals to A minus 50 for this T1, and from here we are going to T2. We will discuss about the discrepancy later. First, let us build the schedule. So now we are having for the T2 the updation on A, writing on A, and then reading of B. Then again we are going to this T1. Now after finishing write to it, we will again move to T2. So now let us calculate the schedule and then see that what leads to this inconsistency. First, the A and B account, we are having 1000 and 2000 as the initial values. Now we are performing A equals to A minus 50, that is my 1000 becomes 950. But we have not write this value from T1. So this 950 is not being updated to the value of A. Now when this T2 is reading the value, it will read the old value of A, that is equals to 1000, not 950. because we have not write any read statement on this T2 before any write statement on T1. So now it is temporary variable, that is 10% of A, which is equals to 100. Now my A equals to 900, and that is my final value for A. Now what it is doing, it is reading the value of B, that is equals to 20,000, that means 2000. Now my A is writing the value. So what value it will write? It will write the value that it has been updated previously. So my A will have 950 now. As A has been performed 900 after this write, and now this write is considered to be the dirty write. So what is the dirty write? That we have written a value of A that is not read by any of the transaction. Again we are writing the value of A. So this becomes my dirty write. Now we are having the value of A as 950 to the final one. Next we are performing B equals to B plus 50, that is my 2000 becomes 2050 on this updation. And we are writing that B2. That means the writing of B becomes 2050 now. Again on T2, we are not reading this value, we are just adding this B equals to B plus 10. So what value it is read to? It will read this previous value 20,000. That means it is 2000 now. So my temp will be considering 2100. So this 2050 will not be affected, and this 900 will not be affected. So now my B is having 2000 and A is having 950, which will result in 350. While the initial result was 3000, my final result is 1000 plus 2150, that is 3050. So what happens here, that we are having the problems of this write we have not made here, only we are reading the previous value. So the old value is being read, which is not written or updated. So we need to consider when we are having a concurrent execution, just like the previous example, we need to read a value that a transaction has been updated. Other than the context switch concept will be not be there in a concurrent execution. So when a schedule is there, it is no longer need to be serializable for the concurrent execution, because it accepts the state of context switch, that one saved state for one transaction will be considered for the next state on this next transaction. But now here we are not saving any state on this data item A. We are just reading the value on T2 for the old value. Now we are writing the value of A, not we are again reading it. That means once we have not saved it, the second one we have not read it. So these are the problems that we face, this T1, T2, and again this T1 on T2. So now we are having this type of problem which leads an inconsistent state within schedule that is made of a concurrent execution. So we need to take care of this type of situation by making the schedule possible within concurrency control mechanism, where we will use different types of techniques to control this situation that we have faced while the inconsistency was there. So that is all for the concurrent execution of transactions. Thank you for watching this video. Stay tuned with Ekeeda and subscribe to Ekeeda.